And here is the final result with the shape and the color as well. As you can see, it gives us some really interesting motion, and it's really easy to integrate color variation into the simulation. So we get some nice final result that can be applied to many different things, from motion graphics to commercials and even VFX if you're working on a fantasy and a magical environment. So let's have a quick overview of how we built this effect. I'm gonna pause this and let's quickly go through what we have right now. So the most important thing, as I've stressed a bunch of times right now so far, is the source. So the source is very important. In this case, we're working with a torus that we transform it. We're just kind of pulling it up a bit. Then we apply a point VOP to apply some noise to the overall shape so that it's kind of wobbly. Okay, we get this kind of initial wobbly motion. Then we add some irregularity to the surface of the torus. So we have two types of disturbance. We have some big scale disturbance changing the shape of the torus, and then we have some small disturbance with the mountain to actually change the silhouette of the main shape. We apply some normals, and then we set a blend parameter that we can use to combine the normal direction with something else. Then we apply the color noise. Finally, we use a transform to make it rotate. And then we calculate the velocity with the trail. We generate a pyro source from that. We grab the density and temperature, and we transfer the velocity to those points with an attribute transfer. And as we transfer velocity, we also transfer the my blend, the normal direction, and the color. So here we're just doing a very simple linear interpolation, where we were trying to combine the velocity that's coming from the rotation and the change at the animation of the mountain with the some bursts of smoke going following the direction of the normals of the surface. We ended up reducing that quite a bit, so it's not really having a strong effect on the final simulation. We also added a bunch of attribute noises, in this case for density, for temperature. Again, always trying to make things more variable, more irregular, with more dynamic as well. And that's all going to contribute to the final result that you saw there. Then we finally volume rasterize all those attributes to convert the source into actual volume. And here on the volume rasterize, just make sure you select all the attributes that you want to grab. Of course, we're just considering density, temperature, velocity, and at the end we added the color as well. On the pyrosim, in order to be able to grab the color information, so don't forget that in terms of setting up the smoke object, standard stuff, just make sure that you define a good size to envelop your simulation. Don't forget to apply a fluid dynamic, a resized fluid dynamic, so that you don't start simulating the whole volume container from the start. And on the volume source, we're grabbing the density and we're adding it to the simulation with a scale of 1.5. Temperature, same thing. So we're grabbing it and adding it with a scale of 1.5. And the velocity, we're scaling it down in this case, but also adding it to the simulation. And the color, we're grabbing it and blending it in using the density. The other thing, the biggest change that we made probably was here on the simulation. We changed the direction of the buoyancy so that we could have the smoke instead of going up due to the temperature, we have it coming in the direction of the z-axis. And that's pretty much it. Don't forget, for the color again, you have to go to the fields and activate the color and the alpha, because they're not they're not on by default. And also here on the Pyro Solver, you have a section for color that allows you to control dissipation, and the same way you control for density, you have control over it specifically for the color. So you get this nice looking smoke portal with some color added to it as well. So this concludes our first week, and I'll see you on the next one.